Right. So first of all, if you have, let's say, whenever you need to find the area under the curve, it'll always be in between two curves. Okay, you can't really just find the area of one curve, right? Most of the cases, what we do is we find, for example, when we talked about definite integrals, the second curve for us was by definition the x-axis, right? That's what we did, right? When we said the definite integral is this, say from point A to point B, this was essentially the algebraic area between the curve and the x-axis between these 2 points, right? So this was my curve 2 and this was my curve 1, right? But in some cases, what might happen is, in this chapter, you might get two different curves, right? Or maybe more than two different curves, right? It could be just simply curve 1 and curve 2, okay? Suppose I want you to find the area between these two curves. Okay, suppose this is curve 1 and this is curve 2, right? And when I say area between two curves, now most of the times you won't be given the points, right? Because area under the curve between these two curves is basically between the points of intersections, right? That's the first thing you need to keep in mind. So these points of intersections are some things that you'll have to find by yourself. So how many points are there? There'll be this point A1, A2, and A3, right? So that's your step 1, finding the points of intersection, okay? Step 2 is always remember, positive area is always going to be the upper curve minus the lower curve, right? Because we saw this, right? If you have a function that's greater than equal to 0, then its integral should also be greater than equal to 0. We saw this, right? It's a property of, definite integrals, and these are both definite, okay? So A to B, right? So in this first interval, what will this area be given by? It's basically going to be integral A1 to A2. What is the upper curve here? C2 lies above C1, right? So it will be C2 minus C1. Plus between points A2 and A3. Now see, C1 is above, right? So it will become C1 minus C2 between A2 and A3. And this is your required area. Does this make sense to everybody? Now, another thing that you need to keep in mind is most of the times you'll get random conics, okay? Which means you need to know the general graphs of some conics, right? Like what a standard parabola, what a standard hyperbola, what a standard circle looks like. And in most of the cases, I could ask you, find the area enclosed by the circle, let's say some x square plus y square equal to a square, right? Let's say I just ask you to find the area enclosed by this curve. Can I give a short recap? Short recap was this is something that we've already seen, right? How do you find the area between two curves? The general idea is, first step, find the points of intersection. Okay, so in this case, we have to find this A1, A2, and A3 individually. Wallis theorem, not really. You don't need it, but if you want, you can do it. It's basically an extension of reduction, okay? But you don't really need to know Wallis theorem. Step 2 is integrate upper curve minus lower curve between the points, okay? So for example, in this first half, the upper curve is going to be C2, the lower curve is C1. So we get, should have been C2 minus C1. So in this first part, you'll get C2 minus C1 integrated between A1 and A2. And in the second part, it will become C1 right now because C1 is greater in this case. C2 is smaller, right? So you'll get C1 minus C2 between A2 and A3. This is your required area between these two curves. Now, in some cases, you might also just be asked to find the area enclosed by the circle. Now, see, it's very obvious, right? It's a circle with radius a, so the area should be what? Pi a square. But how do we prove that? Now, see, this is actually a curve, which is why this entire chapter is called area under the curve and not area under a function. A curve might not necessarily be a function, right? We know that circle is not a function, right? If you draw the circle, it fails the vertical line test, right? For the same value, you get two different, and at the same x, you get two different values of y, right? So it's definitely not a function, but it is a curve, right? Now, to find the areas of such functions, what you need to do is you need to understand what the graph of this curve looks like. For example, this circle is highly symmetric, right? It's symmetric with respect to both the x-axis and the y-axis, which means if I can just find out the area of the first quadrant, I can multiply that by 4 to get the overall area. Yes or no? Does that make sense? So you have to use these shortcuts, right? Because in this first quadrant, if I just focus on the curve here, now it forms a function, right? What is this going to be? In this region, it's nothing but y is equal to plus square root of a square minus x square. Yes or no? This is the entire upper circle, right? This is the upper semicircle. Yes or no? You're forcing y to be positive, which means you get this upper semicircle, right? Now, further, what are the points? Now, this point is x equal to 0 and this point is x equal to a, right? So, what is this area of the first quadrant going to be? Just integral 0 to a square root of a square minus x square dx. Yes or no? Now, you know how to find the area of this, right? You can do whatever you want. You can put x equal to sine theta or cos theta or something, okay? And you can evaluate this. And whatever you get, just multiply that by 4, you'll end up with pi a square is basically 4a1. Does this make sense? So that's how you find these areas, all right? So even in this case, when you're finding this area, deep down you know what your curves are, right? In this case, you're basically finding the area enclosed by this curve between the y-axis, the x-axis, and the curve itself, right? So you have 3 curves essentially over here. But I mean, this one you can ignore, right? Because this is just the initial point. So this area doesn't really count, but you get the idea, okay? Does this make sense? So start off with a simple question. Find the area common between these two parabolas. So you'll need to know a little bit of coordinate geometry for this. Five x square is equal to y and 2x square minus y equal to 9. So these are your two parabolas. Find the area enclosed in between them. This will be minus 9 plus 9 equal to 0. Yeah, maybe. Yeah, thanks. Find the area between curves. Find the area between the curves y equal to 2x to the power 4 minus x square and the x-axis between the points of its minima. And I don't think there's anything else in this chapter. It's just about practice. Like the better you can draw the graphs, that's it. And obviously you need to know a little bit of integration to integrate it. But apart from that, there's no other idea in this chapter. It's just upper minus lower integrated. Okay. Guys, so in this chapter, I'm no longer going to be integrating it for you guys, okay? I'll just leave the integrals for you to do it. It'll give you more questions to practice. I'll just give you the final form and expect that you guys can integrate it, okay? Unless it's it's not 54, it's 12 root 3. So how do you do this? Just draw the parabolas, right? Y equal to 5x square should look like what? It should be a parabola that passes through the origin, right? I mean, even if you don't know what parabolas look like, you know quadratic equations, right? We have done this. So this is what it look like. So this is y equal to 5x square. And the other graph is what? The other curve is what? Y equal to 2x square plus 9, right? So what is so this passes through which point? 0, 9. Okay. Now what do we need to do? First step was find the points of integrations. Okay. This is the upper parabola, right? I mean, just if you just plot it, this is what you'll get, right? This one has 5x square, right? This one has 2x square. So after a few values, which one is going to be steeper? 5x square, right? Okay. Now, how do you find the points of intersections? You solve for y, right? Which means you get 5x square should be equal to 2x square plus 9, which implies 3x square should be equal to 9, which gives you x equal to plus or minus root 3, right? So what are these points? The points of intersections turn out to be nothing but okay. So what is your final required area? Minus root 3 to root 3. And what is the upper curve over here? It's 2x square plus 9. This will become 9 minus 3x squared. Yes or no? Now what do you need to do? You just need to integrate this and find the final answer, okay? This turns out to be 12 root 3. Now if you want to simplify this, you can use all these properties of definite integrals that we know. See, these are even functions, right? Which means the area on the left-hand side of the y-axis should be equal to the area on the right-hand side. So you can just say that this is going to be twice the integral 0 to root 3, 9 minus 3x square, okay? It just turns out to be twice of 9x minus x cube between 0 and root 3. So that's just putting root 3 in the first one. So you'll get twice of 9 root 3 minus 3 root 3, which is 6 root 3 times 2, so just 12 root 3, okay? So you can integrate it whichever way you want, okay? This final step is not the tricky part. The tricky part in this chapter is always going to be being able to draw the graphs properly, okay? Root 2 by 15, which one is this, the first or the second? And it's the answer for neither. You won't get root 2 by 15 for the second one also. Okay, so this is question 1. Is this clear? Try this one. Try the second one. This is a nice question. This will teach you how to actually sketch out graphs from scratch, even if you don't know what it looks like. You'll still be able to sketch the graph. See, what are the things we know about a random function? If you have a random function, so far everything we have done, what does that teach us? First of all, we know wavy curve, which tells us the sign of the graph in different regions, right? We also know about dy by dx indicating the monotonicity of the function, right? So if you get an interval where the derivative is positive, I can say for sure that the function is going to be decreasing at that region. It is 7 by 120, yes. It'll be 7 by 120. There's one more thing. Stop thinking your answer is weird. I mean, I faced it, but it happened to me as well. But getting some random answer doesn't mean your answer is wrong. There's 7 by 120. Okay. As I was saying, first thing is wavy curve, use that. Second is look at the sign of dy by dx. That will tell you the intervals where it's increasing or decreasing. Third step is finding the points of maxima and minima, right? These three pieces of information will go a long way in helping you sketch the graph, okay, of whichever function you have. Might not be very accurate, but you'll still get a general idea of the graph, okay? That's 7 by 120, yes. So in general, when you have polynomials like this, I'll tell you what are the steps you need to follow. It's almost an algorithm, okay? So you have 2x4 minus x square, right? First of all, can we factorize this? Yes, right? X squared times 2x square minus 1. And if I use wavy curve on this, what will I get? This is nothing but, so what are the points you'll get? 0, plus minus 1 by root 2, right? So after root 2, it should be positive. At 0, you have this and you have something like this, right? So in general, I got a negative. You might have taken the sign convention wrong. This is what it'll look like, right? The signs, okay? So at minus 1 by root 2, so in between these two regions, it's negative. Here it's negative. After this, it's positive, right? This is what it looks like. Okay? Okay, you guys must have messed up somewhere anyway. So let's look at how do we get this. Okay? Wait. How did you get it to be 7 by 120? It should have been, the actual question should have been ordinates of its, it should have been ordinates of its minima. Which is slightly different. I'm not really sure now whether you'll get 7 by 120 or not, but let's see. Let's finally evaluate it. So that's the first thing, okay? So it tells us about the sign of the function, right? Now if you look at dy by dx from here, what will we get? 8x cube minus 2x. What is the nature of this graph? If I take 2x common, I'll get what? 4x square minus 1. Right? So now I can say, what does this look like? So half, 0, minus half, right? So the function, see, dy by dx is going to be negative till minus 1 by 2. It's going to be positive in between half and 0. It's going to be negative in between 0 and half, and it's going to be positive after half, right? What does that mean? That till minus half, the function is decreasing. Yes or no? So if I now try to sketch the graph, so this is the graph of dy by dx. I'm trying to get this was just the sine of fx, okay? Now let's actually plot fx, all right? So till minus half, it's decreasing, and we know it's a even degree polynomial, right? So at infinity, we know it goes to plus infinity. So it will decrease till minus half. Check the value at minus half, okay? See, at minus half, it actually becomes 0, right? So it's a point of minima. Fine. So at minus half, it will turn out to be negative, right? Yes or no? It will be what? 1 by 8 minus 1 by 4. So that's negative. So it will come all the way till here at minus half. Then it starts increasing, right? Again, at 0, it becomes equal to 0. So till 0, it will increase. And the value of this function at x equal to 0 is 0. So after 0, it again decreases. And see, at minus half is a point of minima. Wait. This is fine. Your answer should be okay. It's fine. Minus half is a point of minima. Sorry, not 1 by root 2 here. Anyways. So minus half is one point of minima. The other point of minima is plus half. So it will look something like this. And then after that, it strictly increases. So it will go on, right? So this is the final sketch of the graph. 2x to the power 4 minus x square, right? Now you have to find the area in between the points of its minima, right? So minus half and half. Again, it's symmetric about the y-axis. So I can just calculate twice the integral between 0 to half. What is the upper curve? The upper curve is x equal to 0. It should be 0 minus this, right? So did you guys miss out this minus sign? And if you integrate this, you'll get 7 by 120, okay? And plus 7 by 120. So make sure you remember this upper minus lower thing, okay? Because in this case, it was fine. You only have one value, okay? So even if you get a negative sign, you know you made a mistake in sign. But in case it's a function that looks like this, okay? This one becoming negative, and if this one is quite positive, you might end up with the wrong answer, okay? If it's not symmetric, okay? In that case, you'll get the wrong answer. So remember this. That is the only thing you need to remember in this chapter. Upper minus lower, always. See, all you need to do is sketch the graph of this function properly, right? So what are the pieces of information? Actually, wavy curve did not really help us a lot in this case, okay? But do it just for the sake of it. What we did was we looked at dy by dx, and then we checked the sign of dy by dx, okay? No, that's not always true. That's only true in cases of symmetric functions, okay? It's only true for symmetric functions. If you have two different areas, okay, between curves, like this example. So if you get it wrong in one of these intervals, if you get minus instead of plus, and suppose this is positive and it's positive enough to give you the overall answer as like, okay, how do I put this? Suppose the area over here is plus 8, and the area over here is supposed to be 5. The algebraic, the overall geometric area, okay? And suppose instead of 5, you get minus 5. You'll get the overall answer as something positive, right? It's 3, but that's actually wrong, right? Because the actual answer should have been 13. You understand my point? So in questions like this, if you mess up in one of the regions, your overall answer will become wrong, okay? You won't have that option of just changing the sign. Cool? Yeah. So look at the nature of dy by dx, okay? So dy by dx, use wavy curve on dy by dx, right? This is what you'll get, right? What are the points? 0, plus minus half. Now if you plot this, you can see that between minus infinity and minus half, it's negative. Then between half and 0, minus half and 0, it's positive. Then 0 to half, it's negative. And after half, it's positive. Which means till minus half, the function should be decreasing. Okay? Till minus half, the function should be decreasing. Then between minus half and 0, the function increases. And see, these are actually extremum points. These are all critical points, right? Minus half and 0 are roots of this, right? So if you check, you'll see minus half turns out to be the minima of this function, right? 0 turns out to be a point of maxima, local maxima. Then again it decreases between 0 and half. So again the function decreases, and after half it again increases, right? So this is what the graph should look like. Now what is the area you need to find between the points of its minima, right? Which means between minus half and half. Now this function is an even function, so I can just calculate 0 to half. The integral of the upper function minus the lower curve. What is the upper curve here? It's 0. The lower curve is this function, right? So that is your required integral. Why do you want me to solve this? Okay, I'll do it this once, but don't make me do this again and again. Minus 2x to the power 4. What will you get from here? X cubed by 3, right? Yeah, better not skip steps. So it is what? $16,580, right? That's it. Okay. Don't get integrals of algebraic functions wrong. These are the easiest integrals you can solve. Cool. Okay. And you might get a few other questions. So where you might need to use some elementary geometry as well. So let's try this one. Find the area. These are nice questions, okay? So try this. Find the area. Area of the region given by x plus y is less than equal to 6. X square plus y square is less than equal to 6y. And y square is less than equal to 8x. Find the area of this region. Second is again similar, find the area. I'll use Desmos for drawing the graphs of this, okay? But you should be able to draw it on your own. All points x and y such that 0 is less than equal to y, it's less than x square plus 1. 0 is less than equal to y, and it's less than equal to x plus 1. And x lies in between 0 and 2. Find the area of these two regions, okay? Okay, just a general idea if you guys don't know this. If you have a random random curve, okay? Say some fxy less than equal to some number c or something like this, okay? Basically, all the graphs look like this only, right? How do you figure out which region you need to consider? I mean, you can plot fxy, right? It'll be something. See, fxy looks like this. So how do you figure out which side should you take less than, which side should you take greater than? Always remember, just put the value of x and y as 0 in this, okay? Put x and y as 0. The side which satisfies, wait, how do I put this? How do I put this? Yeah, but x equal to y equal to 0. If origin actually satisfies this, then it's the side which contains the origin, okay? Yeah, basically, yeah. So if origin satisfies, it's the side that contains the origin. If it doesn't satisfy, then it's a side which does not contain the origin, right? For example, in this case, suppose 0, 0 satisfies this, then this is the region that you're looking for, right? But if it does not satisfy, then this is the region that you'll be looking for, all right? So remember this. I'll just do it for one of these. For example, if you look at x plus y less than equal to 6, first draw x plus y equal to 6, which is this line, right? See, 0, 0 does satisfy this, right? 0 plus 0 is 0, which is less than equal to 6, which means this is the side that you're looking for, okay? So this is the region given by x plus y less than equal to 6. You need to get used to it, like drawing these graphs. I mean, finding the exact region is like whenever you're drawing figures like this, make sure you do it properly, okay? Don't just scribble. Then you just have to keep on doing it 2 or 3 times. The first time that you're drawing the figure, make sure you draw it properly so that, yeah, like just doing it once is enough. I'll first show you how to do it, like without a calculator, but then I'll use a calculator so that you get a proper image that you can understand. Okay. It just allows you to add, subtract, multiply, divide, and take square roots, if I'm not wrong. I mean, I don't even think you can take nth roots in that, but I forgot. I mean, it's been a long time. Gate calculator. Is that the same? Fine, then use it. 4 pi by 9 plus 11 by 6. Nope. Close, but the first term is correct, but the second one is wrong. I saw no calculator on the screen, which where did you not see? Anyways, let's see. Okay, first of all, x plus y less than equal to 6 is easy to plot, right? Should I do it on the same one? Okay, this is how you do it, okay? Start with the first one. We know x plus y equal to 6 is this, right? And we know that we need to take the region below it. So that's the first one. Second one is, what is x square plus y square minus 6y? There's nothing but a circle, right? This is nothing but x square plus y minus 3 whole squared equal to 9, right? So it's a circle with center 0, 3 and radius equal to 3, right? So what does this look like? Okay, maybe I should not have erased it. Yeah. This is what you get, right? It's a circle with center 0, 3 and r is equal to 3. So you get something like this. What is this point? This is 6, right? This is what the circle should look like. Okay. And if you're looking for x square plus y square minus 6y, right? Less than equal to 0 for a conic always means interior of it, right? So for a circle, it's going to be points inside it. Cool. And the third one is y square equal to 8y, right? If you draw that, that's nothing but a parabola, right? So if you want for a better idea, I can actually solve all these points first and then, draw it, okay? Yeah, minus 1 by 6, I think. Yeah, 1 second. Yeah, minus 1 by 6, right? Nice. If we plot the parabola, it looks something like this. Okay. This is what you'll get, okay? So the actual area you're looking for is basically this, right? Let's shade this with white. This is the area that you're looking for, okay? Cool. Fine. Okay. Now I'll draw this properly using a graph and then I'll tell you how to find these areas, okay? Does this allow less than equal to? This does not allow x plus y. It doesn't even have an option for y. Oh boy, this is bad. I could just go to Desmos and do it separately. I mean, like, if you don't get the figure properly, you won't be able to understand. So let's go to Desmos maybe. Yeah, this is better. Okay, that's the first one. What was the second one? The circle, right? So x square plus y square minus 6y less than equal to, less than equal to 0. This is what you get. And the third one was y square less than equal to 8x, right? Cool. Zoom it out a little. So you also get your points from here, okay? 2, 4, whatever this point is. We don't care about it. This point is what we need, okay? So these are the points we need. So I'll take a screenshot of this. So it's exactly the same figure I got, but yeah, just for the sake. Yeah, these points, they calculated it directly. You need to calculate it manually, okay? So this is what you'll get, all right? Now see, to find this area, I can split this. So this is the required region, right? This part. Yes or no? That is the thing that's bounded between these three curves, right? So this is our required area. Now, how can we find this? Now, easiest way of finding this is split this into two regions, okay? One till this point of intersection, and one between this and this, right? So if I look at the first area, let's call this A1, let's call this A2. So what can I say about A1? A1, the upper curve is this, the parabola. The lower curve is the circle, right? Yes or no? And there's this line as well, right? So what will be the first area? A1 can just be written as integral 0 to 2. Upper curve is the parabola, right? So y square less than equal to 8x equal to 8x. So y is equal to 2 root 2x, right? Minus the lower curve is given by the circle, right? So can I solve for that? Solving that might be a little difficult. 1 second. It has a linear term. Oh wait, I simplified it, right? What was it? There's nothing but x squared plus y minus 3 whole squared equal to 9, right? So y minus 3 is 9 minus x squared. I get either positive square root because we're in the first quadrant. So y is nothing but this plus 3, right? So this is your second function, okay? So minus is a plus 3, so that'll become a minus 3 dx, okay? So this is the first area, right? Does this make sense? Now when it comes to the second area, what do I have? It's the upper curve is now the straight line, the lower curve is still the circle, right? Yes or no? So this area 2 can be written as integral 2 to 3. Upper curve is x plus y equal to 6, right? So 6 minus x minus, again the same thing, right? So your final required area is A1 plus A2, which turns out to be, what was it? 9 pi by 4 minus 1 by 6. Cool. And these are easy integrals. We have just seen how to solve a square minus x square, right? Just take it to be a sine theta or cos theta and you'll get it, okay? Don't make me solve this, please. But you understand. Actually, you need to be able to draw these graphs properly. Otherwise, see, unless we drew the graph properly, we would have never visualized that we could split this into area 1 and area 2, right? Does it make sense? So this is how we get the final area, right? Is this clear? Okay. Any questions, anyone? Fine. Try this one. Similar idea, so you should be able to do this quickly now. Find the area of this region. See, in general, whenever you have multiple regions like this, what you're actually looking for is the intersection of the three regions, right? That's exactly what it did in this case, right? This is the part that encloses all the three regions, right? So in general, whenever you have something like this, your final required region is nothing but the intersection of all the regions that are already defined for you, right? This is the part that you're looking for. So it should be intersection of this region times this region times this region, all right? One question. I mean, you can expect one question for sure from this chapter. How to determine what curve lies in which quadrant? That should be obvious if you draw the graph properly. You don't have to figure out the quadrants separately. We draw the graph first and then we look at the quadrants. And for example, y square equal to 8x, we know it has to be in the first and the fourth quadrant, right? So it just depends on the nature of the graph. It'll take some time, yeah. I mean, questions from here are not really very straightforward. I mean, they are straightforward, it just takes some time, okay? Okay, this is comparatively easier than the first one. So what are the three regions you have? Firstly, you have y greater than equal to 0, less than equal to x squared plus 1, right? So in case you have inequalities, don't just get scared because there are inequalities on both the sides, okay? Just simply plot the graph and see what happens. So y equal to x squared plus 1 looks like what? This, right? Yes or no? See, y by default is already greater than equal to 0, right? So what is the part you're looking for? Greater than equal to 0, but less than equal to x plus 1, right? So basically this region below the parabola, right? And above the x-axis, obviously, right? Does it make sense? So that's the first one. Second one is, what was the second one? The straight line, right? Y less than equal to x plus 1. Now see, x plus 1 and let's figure out the points of intersection of this line with this curve, okay? If I put x plus 1 over here, this gives two solutions, right? 0 and 1, which means it will intersect this graph twice. Okay, and actually I think the line looks something like this. Okay, something like this. Okay, so there's a small tiny region formed between these two. Okay, so like I said, this is like me plotting it roughly. I'll also do it on Desmos and give it to you. So that's the second one, right? And now what was the third region? Third region is x in between 0 and 2, right? So x in between 0 and 2 is basically this and this, right? Somewhere around here. I don't know, say here. Okay. Now, what did I say? It should be the intersection of all the regions that is given to you. The first region is below this parabola, right? Second region is below this line. Third region is in between these two. So what is the final intersection? It's not 4. How is everybody getting 4? It's not going to be 4. It should not be 4 if I'm not wrong, unless this answer is incorrect. This is the region that you'll get, right? So be careful, we are not actually including this tiny area in between, okay? It's just going to be this area. Cool? Fine? So if I draw this on Desmos, what will I get? What was it? X squared plus 1, right? That's the first one. Second one was, what was it? Y greater than equal to 0 again. Okay. The third one is x in between 0 and 2, we already know, right? So let's just draw x equal to 2 anyways. Equal to 2. Yeah, somewhere around here, okay? So this is what it'll look like. This is what we get, okay? So what is our required area once again? So I can write it as, see, between this point to this point, it's nothing but the area under the parabola, right? It's not 8 by 3. Not 8 by 3. So between the points 1 and this, what was this? This is x equal to 1, right? So it's going to be integral 0 to 1. The upper curve is just x squared plus 1, lower curve is x equal to 0, right? So it should just be this integral plus, what is A2 going to be? The second area. It's going to be between this and this. Now the upper curve is just this, right? And the lower curve is this, right? So it's just integral 1 to 2 x plus 1 dx. Just add these two. Whatever you get is your final answer. And see, this turns out to be what? This should turn out to be 23 by 6, exactly. Yeah, it turned out to be 23 by 6. Simple. So this is way easier than the first one. How did so many of you get 4? Is this clear to everybody? Does this make sense? Integrate 0 to 2. But this, yeah, exactly. So this area is not included, right? You can't include this area. Because this region does not lie inside R1, right? R1 is below that. I don't know, I never did LPP. I know you do something with this, like less than equal to, greater than equal to, but LPP follows from graph, okay, not the other way around. So, yeah. Anyways, try this one. This is also a nice question. Suppose I define a function fx, which is going to be square root of fractional part of x if x is not an integer, and it's just equal to 1 if x is an integer, okay? This is how I define my first function, and I define gx to be fractional part squared. Fx and gx between x equal to 0 and x equal to 10. Yeah. In general, yeah. For any area under the curve, plotting the graphs is going to be your most difficult task. अरे यार तुम लोग इंटीग्रेशन गलत मत करो भाई लीनियर फंक्शंस का I mean algebraic functions का कैसे first one is going to be what x cube by 3 plus x, right? So that this turns out to be 1 by 3 plus 1, so 4 by 3 आया यहाँ से. Second one is going to be x square by 2, right? So 4 minus 1 by 2 plus 1, 3 by 2 plus 1. 3 by 2 plus 1 is 5 by 2. 5 by 2 plus 4 by 3 कितना आएगा? 4 2 is 8, 5 is 15, 23 by 60 तो आ रहा है. Second one is 5 by 2, not half. How is it coming half? 3 by 2 आएगा plus 1 आएगा. X का इंटीग्रल ही तो 3 by 2 आता है between 1 and 2. और यहाँ से plus 1 तो आएगा ही. Integral of 1 itself is going to give you 1. How are you getting half for A2? यार ये सारी गलतियां मत करो, फिर कोई फायदा ही नहीं होगा क्वेश्चन करने का. अगर ग्राफ वगैरह सब सही बना के तुम x plus 1 का इंटीग्रल गलत निकाल रहे हो. Oops, I just forgot that this is the English batch. My bad, sorry. You can't get these integrals wrong. This is just, these are the simplest functions to integrate, right? It's not even square root of something. You can't get these integrals wrong. Then all the effort you put in drawing the graph is just going to get wasted. Okay. So make sure you don't do that. What about this one? This is very easy. If you're like slightly smart, you'll do this in one step. Whenever you get something like fractional part, what is the first thing that should come to your mind? And you're integrating it over a region. No. I mean, which is what I said when you're talking about integrals. Yeah, it will be 10 by 3. Nice. When you're integrating it, the first thing that you should remember is that it's a periodic function, right? Yes or no? Fractional part of x is a periodic function. So if I try to plot the graph of this, say this is x equal to 0. So whatever happens between 0 and 1, that is the same that's going to happen between 1 and 2. That is the same that's going to happen between 2 and 3, and so on and so forth, right? So if I can just integrate it somehow between 0 and 1, I can just multiply that by 10 and I'll get the overall answer, yes or no, because both of them contain the fractional part. Does that make sense? Now between 0 and 1, if I talk about 0 and 1, fractional part is just equal to x in this region, yes or no? Because every number over here has, GIF part equal to 0, right? So between 0 and 1, fractional part of x is just equal to x. So what will the first function become? It will just be square root of x, right? Yes or no? And what about the second one? This is just fractional part of x whole square, which means g is going to look like just x square. I mean, ignore the endpoint, okay? I don't care what happens at the endpoint. But in the rest of the region, this is what it's going to look like. Now, if I can somehow just find this area, I can multiply it by 10 to get the overall area. Yes or no? Because even in the second part, because it's periodic, it will look like this, right? And so on and so forth. So what should be your final answer? This integral 0 to 1, root x minus x square dx, and this multiplied by 10. This, I guess, turns out to be 1 by 3, so your answer turns out to be 10 by 3. That's it. As simple as that, okay? So yeah, it was a very nice question. The graph part. See, between 0 and 1, first things first, fractional part is periodic with period 1, right? Yes or no? Which means whatever happens in the first interval, 0 to 1, is exactly what is going to happen in each of these intervals, 1 to 2, 2 to 3, and so on and so forth, right? Again, you'll copy this to 2, between 2 and 3, and so on and so forth, right? Now, so we are just concerned with what happens to f and g between 0 and 1, all right? Now, between 0 and 1, fractional part of x is always going to be equal to x, yes or no? Because over here, what do we know? Fractional part plus GIF is equal to x, right? GIF between 0 and 1 is what? It's 0. So fractional part will just be equal to x. That's it. These are all fractions themselves. And we know for positive fractions, fractional part is equal to the fraction itself, right? So what is f going to look like? F is what? Square root of fractional part of x. So it will just become root of x. This is the graph of root x. Similarly, g is fractional part squared, right? That's just going to become x squared, right? So the second graph just becomes x squared. So you have to find the area in between these two curves, which turns out to be root x minus x squared dx. And what do you do to find the overall area? Just multiply it by 10, right? Because in each of these intervals, the 10 intervals, the area is going to be the same. So the overall answer turns out to be 10 times this integral, which is 10 by 3. Okay. Try one more, and this will be the last question. I don't have anything else. It's going to become repetitive after a point. Okay. Mod function. Someone said mod. And there's nothing okay, I'll give you a mod, okay. Right, and there's nothing special about mod. Find the area of the region. Area of the region between y equal to x square, y equal to mod of 2 minus x square, and y equal to 2. Find the area of the region between these three, which lies on the right hand side of x equal to 1. Cool. There's this region which lies on the right hand side of x equal to 1. That is what you need to find. It's not. Okay, start off with the most complex graph, which is mod of 2 minus x square. So if you start off by drawing just 2 minus x square, what happens? Yeah, it's 20 minus 12 root 2 divided by 3. Yeah. Nice. There's a final answer, okay. So y equal to 2 minus x square will look something like this, right? And what happens? What is the easiest way of finding mod of something? Wherever it's negative, just flip it upwards, right? That's it. Okay. So mod of 2 minus x square should look something like this, right? This, right? Then this. Something like this, right? And what will these points be? This will be root 2 and minus root 2. Okay. Now what is the second graph? Second graph is y equal to x square. Okay. And if you look at these graphs, if you look at x square, what is this region? I mean, in this region, what does this graph look like? It's the negative of it, right? So it basically becomes x square minus 2. So this graph behaves as x square minus 2. This part it behaves as 2 minus x square. Again on this part it becomes x square minus 2. So y equal to x square in some sense should be parallel to this at every point, right? So it will look something like this. Okay, so the only point of intersections would be here. This is y equal to x square. Why is it a circle? Which one is a circle? Okay. And what was the third line? Third line was y equal to 2, right? So you want y less than equal to 2, which means this line. So you want things below this? Yes or no? And let's look at these point of intersections. 2 minus x square equal to y equal to x square would give you what? X equal to plus minus 1. So this point is minus 1, this point is plus 1. So what was the final statement of the question? The region that lies on the left hand should have been right hand side. Okay. Should have been right hand side. Change it. But anyways, I don't know the answer for the left hand side. Change it to right hand side. Okay. How do you get 20 minus square root 3 for that? Basically, I just wanted this area. Okay. Not this entire area. My bad. I don't know then what will the answer be. It's not a semicircle. It's not any of those. It's some random curve. But fine, I'll tell you how to find the other one. I mean, the other one is also easy, right? It's just going to be this and this extra integral, right? Anyways, if you want to find this on the left hand side of one, let's go with the actual question. What will that give you? First, this area. Let's say this overall area is just twice of this area, right? So I can just find this and multiply that by 2. So I'll get twice integral. This point is 1, right? So between 1 and 0 and 1, which is the upper curve, this part is 2 minus x square. So it will be 2 minus x square minus x square. This is a1, okay? So this is twice a1. Plus the integral. See, if you don't want to deal with negative coordinates, you can just find this integral as well, okay? But for finding this, see, this integral, if I call this a2, then this integral is also going to be a2, right? Because it's symmetric. Okay? Now for finding this integral, observe that what is this point? At this point, what are you getting? If you put x equal to root 2 in this, and this is x square minus 2, right? What will you get? 0, right? So this point is actually on this line. Y equal to x equal to, oh wait, 1 second. Nope. What is the point where this cuts y equal to 2? So you want x square minus 2 to be 2. So x equal to plus minus 2. Okay, so it's actually further this side. Again, I need Desmos for this. So mod of 2 minus x square and y equal to just x square. Right, this is the graph. This is root 2. Oh, this was x square, right? Oh, my bad. This was x square, not x square minus 2. My bad. This is x square minus 2. Anyways, I took the wrong point. But if I just take this, I need these 2 points. This point actually lies on the straight line, okay? So this would become something like this. Oops. 1 second, it froze. Right. So this is the only region that's left, right? This is the area that we need to find. So for finding this, observe that between this point and this point, this is the upper curve, this is the lower curve, right? So I can further split this region into two parts. Let's call this A3 and let's call this A4. Then what is A3 going to look like? There's space to write it here. A3 should just be the integral from 1 to root 2 of x square minus, what is the lower curve here? It's still 2 minus x square. And what is A4 going to be? Root 2 to 1. What is the upper curve now? The upper curve is just y equal to 2, right? So between root 2 and, what is this point? 2, right? Root 2 and 2, it's going to look like 2 minus x square minus 2. Yes or no? So these are the other regions. So A3 plus A4 is going to give you this required area, okay? This entire A2. Fine. So A2 plus 2A1 is the entire area that lies on the left-hand side of x equal to 1, okay? And again, these are easy to calculate because these are just algebraic, okay? I mean, it's lengthy, but it's not difficult to find these integrals. Does this make sense? How the graph looks like Loki's helmet. True. Is this clear? Take your time, just draw the figure properly and then just evaluate these integrals, okay? Fine. Like, so this entire chapter just heavily relies on you being able to draw the graphs properly, finding the points of intersection, and the third step is upper minus lower, okay? Sure, you can practice questions from any paper, it's up to you, okay? The more the number of questions you practice, the better you get, okay? So, yeah. So I'll upload the DPP, practice those questions, that should be more than enough. I mean, see, after a certain point, questions will get repetitive, okay? There's not a lot of variety you can put in this chapter. The graphs might vary, but they'll just be different variants of the same thing, okay? It'll be different variants of a parabola or a circle or a hyperbola or something like that, all right? But apart from that, there's not a lot of variation that you can put in this. So I guess that'll be it then. See you guys. We'll start with differential equations next. So yeah, that should complete our calculus part. You see, yeah, sure. You can practice from the book as well. It's up to you. Yeah. Cool. All right. After calculus, I'm not really sure. Like, as you can see, I changed the schedule a little even with doing this. But after this, I think I'll go back to the original schedule. Okay, so we'll again continue with algebra topics. Probably matrices and determinants, but I'm not really sure yet. Matrix determinants, PNC, probability, will do these after this. Okay. Cool. That should be it. See you guys then. Bye bye.